Hi and welcome to video 5 of this unit for topic 4, probability density functions of continuous random variables topic and also normal distribution, but we're just finishing that probability density function of continuous random variables component of the topic by talking about medians and percentiles. This is a little bit far out on the syllabus. It's in the extra stuff that you need to know, but it's probably unlikely to be asked, but it's a really nice little topic for you to get your head around, as it actually applies quite nicely to how probability density functions work. So I do want to talk about it. So it's median and percentiles. You may not have heard of percentiles. I'm going to introduce deciles to you today as well, but they're fairly simple things to work with. So recall that the median, or for a median, there needs to be 50% on one side and 50% on the other side of the data. The median's in the middle. And so it's not affected by outliers quite like a mean is. It just represents a middle marker in the data, irrespective of how far away the data is from that middle. So let's say we've got a probability density function that looks like this one, where I've done the orange annotation. And you'll see I've drawn a little dotted line there with an A. And that A, I'm saying, represents approximately the median. If it represents the median, because over here, any probability density function has an area below the curve of 1, this means that the area on either side of the median has to be 0.5, a really important feature. So if A is the median, then the integral between A and 0, and I've got 0 in this case, but A and the lower bound has to be 0.5. So if this was a probability density function with just random boundaries, C and D, I've pre-written this because my OneNote just crashed. P of x would be equal to f of x between C and D, and A, which is the median, would be the integral between, the median, not A, the median would be equal to the integral between A and the lower bound C. So C would be wherever that lower bound is there somewhere, of f of x dx, and that would have to be equal to 0. And so that would have to be equal to 0.5. We don't have to write the median. There we go. That would have to be equal to 0.5. That makes more sense for that to work, and A would then therefore be the median. So let's have a closer look at percentiles then. A percentile splits the data up into percentage points. So I've got that data and I've drawn it out, and you'll see here I've deliberately tried to make it a bit closer here, so there's more data here, so each 10% marker in here will be closer together, whereas down here the 80%, the 90% goes on, 90 to 100% goes on forever, 10% sort of represents a larger chunk. That's the idea. If you wanted to calculate the 16th percentile, that would be somewhere between the 10th and the 20th percentile, and it would be the value such that the integral between b and 0, or b and c in this case up here, of the function f of x dx will be equal to 0.16. So we use 0.5 for the median because that median is actually the 50th percentile. It's the middle of the data. The 16th percentile would be 0.16. And this is really important. I've started my function at 0. It could begin at 1, 2, 7, 0.16. It could begin at c, whatever. It could begin at the negative. We don't know. Anyway, here's an example again. Given a continuous random variable with probability distribution there, p of x equals that, or otherwise, calculate the median, the 30th percentile, or the 7th decile. So let's start with the median. A, we want a value such that a to 0 of x over 16 dx is equal to 0.5. We don't have to use the 4 root 2 this time, just a to 0. And I can do this on my calculator. So I go to my calculator and I do the solve function. So to do the solve function, I go back to my options, calculate, solve n, and I'm going to solve the integral, and my integral is x, I have to use x, over 16 dx. Oh, no, see, I'm going to use a here still. 0, and I'll use an a there, and then I'm going to solve that. I want this to be equal to shift equals 0.5, comma, now I want to solve this with respect to a. Close brackets, execute, spins a bit, says more solutions may exist, -4 and 4 are the two possible answers. So I go back here and 50% of the data exist at or below 4. -4 exists as well because this function obviously does continue. So if I go back to here, the area between 4 and 0 of x over 16 dx is equal to 0.5, and therefore a is equal to 0.5. Sorry, a is equal to 4. Now let's do this again, but for the 30th percentile. So this time it's b and 0 of x over 16 dx has to equal 0.3 because that's the 30th percentile. And so I go to my calculator again and I do the same thing, but I might save myself the hassle. I'll leave the a there in my calculator and I'm just going to change that 0.5 to 0.3 and press enter. It should be less than 4. And it's 4 root 15 over 5, which if I press S to D, give me 3.098. But I like 4 root 15 over 5, but I just wanted to check it was less than 4. So therefore B is equal to 4 root 15 over 5. Obviously you could solve this analytically as well by actually doing the integration, but I'm showing you that it can be done on the calculator. And the integral between C and 0 of x over 16 dx, this is for the decile calculation, is the 7th decile is, I'll give you a second to think about it while I ask you this. Why would you take a piece of toast on a trip to Brisbane with you? Because it goes really well with the traffic jam. So the 7th decile will be 0.7 because deciles are each 10th, i.e. dec. And so I'm going to go back here, should be greater than 4 we hope, and I'm going to put that 0.7 into the function. We're still getting our negatives, but that's okay. And I press enter and I wait for the circle to spin a bit, and then I press exit and it comes up with 4 root 35, which is greater than 4 but less than the upper bound 4 root 2, so I'm happy with that. 4 root 35 over 5 is my answer. So therefore C equals 4, got ahead of myself there, root 35 over 5. So that's how we calculate median, deciles, percentiles, all that kind of stuff, and hopefully it makes sense that if you look at these diagrams, we're looking for percentages, probabilities represented as areas, and if we can use those areas and associate it with integration quite nicely. All the best.